So, continuous delivery. My experience in ThoughtWorks generally has large enterprise clients, and the process in large enterprise clients is basically you have this like agile thing, and that happens in the engineering part of the organization. And you know, anyone work in a corporation or a company of larger than 1,000 people? Okay, so that's about half of you. And has anyone been subject to the agile transformation? Has anyone? Oh yes, loads of you. Okay, so you know how this goes. Some senior dude decides we're going to go agile, and then they hire loads of certified Scrum Masters, and everyone goes on the 2-day Scrum course, and suddenly you're all taking orders standing up rather than sitting down, and that huge backlog of work that you can never possibly complete is now prioritized and estimated, and now we're agile. Tick, yay. Is that familiar to anyone? Hopefully, yes. Even hands going up, even just before lunch, so that's obviously resonated with a few of you. So even if you manage to do the whole agile thing and you're doing, you know, iterations with analysis and development and testing and, you know, nice showcases of working functionality every couple of weeks, what typically happens is that stuff doesn't actually go live, all right? So let's calm down, everyone. What happens is when the project is finished, that stuff gets tossed over the wall to testing, and then they go and log lots of defects, and then you have to remember what you were doing when those defects were logged and try and fix them. And then at the end of that process, assuming you actually get time to fix some of those bugs, the whole thing gets tossed over the wall to the operations team, who then have to try and make it work. And that's usually when you find out that it works great with 10 users, but not so great with 10,000 users, which you were, you know, supposed to be getting, and the 100,000 users or 1 million users that you actually end up getting. And then you spend the whole weekend trying to make the system work and trying to take bits of it down so the rest of it will work, and so forth. And this is a very common and unpleasant experience. And so typically, you know, as a developer, how many people in the room are developers? Whoa, okay. Anyone who's a tester? Okay, a couple of people at the back, I noticed. Yeah, round of applause to the developer, testers. Yay, thanks. Good job. And any operations people? Okay, a few of you, and even at the front. Okay, excellent. So welcome to you guys. So hopefully everyone is familiar with this. As engineering people, as developers, you try and get stuff dev complete, right? The dirty secret of IT is that dev complete is essentially a meaningless term. What actually matters is, does it work in production with realistic data sets under realistic load, and when things go wrong? And that is very far from dev complete. And this part from dev complete to actually delivering value is often called the last mile, which is kind of a dumb term, right? Because it's only at this point that your stuff actually starts delivering value, right? That's when you start getting a return on your investment. That's the first mile. That's the beginning of the life of your system. And then hopefully, if you've done something right, then your system will live for a reasonably long time. And that will be the bulk of the consumption of resources and work on the part of everyone actually building the system. So I've worked in this environment. It sucks. It's a stupid way to develop software, and we shouldn't do it anymore. And that's basically why me and a bunch of other people in ThoughtWorks, and indeed a bunch of other people in many other areas independently, came up with these ideas. Can we do better? Yes, we can do better. If you go to code.flickr.com, scroll down to the bottom, you can see they're deploying to production multiple times a day. Facebook deploys once a day. Etsy deploy multiple times a day. Amazon deploy multiple times a day. Yeah, this is actually very common these days for web-based systems to be deploying multiple times a day. So yes, we can do better. I was kind of trying to come up with a title for the book, and I'm really bad at names. I was once in a band called the Chutney Ferrets. And so I was kind of, the year the book was published was the 10-year anniversary of the Agile Manifesto. And I read the Agile Manifesto, you know, and you know, everyone knows this over that, but there's also 10 principles. And the first principle of the Agile Manifesto is this. And I read this and I kind of went, well, yes, obviously, this is why we all get out of bed in the morning, right? Whatever we do. And so this is a really good title for the book. So how do we achieve continuous delivery? This is how we do it. Hopefully, you're testing your software. Who has automated tests that they run that actually find real bugs? Okay, that's a decent proportion of you, maybe 2/3. So hopefully we run those pretty often, ideally every check-in. But how many people are testing their configuration changes if they change, the number of threads in their database connection or their Apache configuration? How often do we test that in the same way that we test our code? Anyone doing that? Okay, much fewer of you. How often are we testing database schema changes and automating database schema change rollout? Any of you? Okay, a few of you again, much less of you. Any change to your system can break your system. I can bring your system down much more quickly by changing an Apache setting than I can by introducing a bug in the code. It takes ages to get a bug in the code live, right? But changing an Apache setting, bang, there goes your system, down. So why aren't we testing those changes in the same way that we're testing our code changes? It's nuts. Any change to our system should be tested and validated in the same way as code changes. And the idea is with continuous delivery is that we're performing those validations all the time. And we get rid of this waterfall-y system. Instead, we start building what in the lean startup movement is called the minimum viable product, and iterating rapidly and making sure that our software is always production ready, that we can always release our software at any point, that I can take the latest good build, press a button, release it into production, and be confident that it's not going to break anything. So we never are trying to, we're basically removing that last mile altogether. That goes away. And what that means is when you as an engineer say I'm dev complete, what you mean is I'm actually ready to go live. Done is no longer dev complete. Done is release into production. And hopefully I learned whether what I did was a good idea in the first place. And then what that does is it creates this magical transformation where instead of releases being tied to how long it's going to take for a change to go through the change advisory board, instead we're constrained by whether the business thinks it's a good idea to release. The business is never asking IT, can we release now, can we release? No, we have to wait 2 weeks for the next release train to go out, or a month, or, How many people are releasing at least once a year? That should be everyone. Who's not releasing at least once a year? Anyone? Okay, well, no one's going to admit to it. Fair enough. Who's releasing at least once a month? Okay, it's about half of you. How many people are releasing at least once a week? Okay, a handful. How many people are releasing at least once a day? Okay, a couple of you. More than once a day. Congratulations, sir. Only dude in the room. That's cool. So that's a magical thing. Because what happens in that situation is someone says, well, maybe we can try this out. And you go, yeah, sure, I'll code up something that is a proof of concept for that idea. And you push it out there and you gather some metrics and you find out, is that a good idea? Often it's not, it turns out. This is the problem with waterfall, is that anytime you have an idea, we should build this, usually you will be wrong about that, especially when you get into the detail about what you're building. That's the biggest source of waste in the software development process. Stuff that we build that's never used or rarely used. So what happens when you move to continuous delivery is you can get really fast feedback on your ideas and waste all that time that you were building stuff that no one's going to use and actually focusing on building stuff that's valuable. And it transforms the way the organization works. It's really magical. Anyone who's moved to this way of working, nobody wants to go back to the old way. No one's like, oh, I wish we could have releases once every year again. That was so much better. No one says that. Everyone's like, hey, this is really awesome, and we should totally, if you move from an organization that does that to another organization, it really sucks. It's wildly unpleasant. So how do we do that? 3 ingredients. Automation of build, test, deploy, all those processes that are often manual, a bunch of patterns and practices, and collaboration between everyone involved in the delivery process. That's how you achieve continuous delivery. And there's 3 ingredients. 1, configuration management, which means I should be able to take a box, plug it into my rack in my server farm, plug in the power, plug in the network, and have that box serving transactions in a completely automated fashion. I should be able to provision that box, provision the OS, provision the middleware, configure the middleware, deploy the correct version of the application, configure the router, configure the storage in a fully automated way, and have that system provisioned and processing transactions in a fully automated way. As a developer, I should be able to take a new workstation, plonk it on my desk, plug in power, network, VDU, keyboard, all that stuff, and be able to run a single command to check out from version control everything I need to build and test and deploy the system to any environment I have access to, and be able to do that using a single command. That's what we're aiming for in terms of configuration management. Second ingredient is continuous integration, which I'll talk about in just a minute, and then the third ingredient is automated testing. So, who in this room practices continuous integration? Put your hands up. Okay, keep your hands up, keep your hands up, keep them up, keep them up. Put your hands down if everyone is not checking into mainline, into trunk, at least once a day. If that's not true, put your hands down. If you're working on feature branches that aren't merged into mainline at least once a day, put your hands down. If every check-in does not result in a build and a run of all the automated tests, put your hands down. Okay, the people who still have their hands up are doing continuous integration, so congratulations to you. It's about a third of the room. Continuous integration is not running Jenkins on your feature branches. Continuous integration is a practice, not a tool. One of my favorite presentations on continuous integration is by a guy called James Shaw, who wrote an article called Continuous Integration on $1 a Day, where he describes how to do continuous integration using an old workstation, a rubber chicken, and a bell. And it's just about, I make a change, I get the rubber chicken, no one else can check in while I have the rubber chicken, I go to the workstation, I check out trunk with my changes on it, I run the build, I run the tests. If it passes, I ring the bell, ding, and then someone else can get the chicken. If it goes wrong, I keep the rubber chicken. I have to fix the change that I made that was bad. Or if I can't do that in a few minutes, I have to revert it from version control so other people can continue working. That's continuous integration. Continuous integration, the key word here is integration, which means that all the changes are integrated into mainline. If you're not integrating your changes into mainline, then you're not doing continuous integration by definition. You cannot have feature branches that last for more than a day and be doing continuous integration because it's a contradiction in terms. Okay? Now, there may be valid reasons why you're doing feature branching, and there aren't actually that many, but you can't say you're doing continuous integration and be doing feature branching. It's just not possible. So, I've kind of described the workflow for continuous integration. I build something. If it passes, I get the latest from trunk and merge and check that my changes don't conflict with someone else's changes. If that passes, then I push my changes back into trunk, and then that triggers a build which runs the automated tests. And if that all passes, then yay, I've done a really great job. And the key thing is this, what we just described. Everyone's committing into trunk, into the main line at least once a day. Continuous integration. Automated testing. My favorite quote about quality is this one from a guy called W. Edwards Deming. And he has this to say. This is applied to manufacturing, but the same thing applies to software development. And this has two really important implications for software delivery. Implication number one, testing is not something that you should do after you've developed the functionality. Testing is something that we should be doing all the time. Mass inspection in software means manual regression testing after development is complete. And that's crap. It's a really terrible way to get a high-quality product, and it's a massive waste of your precious resources, your human beings. If human beings are doing manual regression testing, that's a massive waste of human resources. As my colleague Neil Ford says, he was here a minute ago, he's just left, probably because he's heard this before. If humans are doing the things that computers could be doing instead, all the computers get together late at night and laugh at us. This is nowhere more true than if you have human beings doing regression testing. It's stupid, it's a waste of time. Humans are really bad at doing repetitive, boring things over and over again. We suck at it because it's just so boring. And when you suck at doing something that's really crucial to the quality of your product, you should probably think of another way to do it. So we should all be testing all the time, which means building a comprehensive suite of automated tests. And the second thing is, testers are not responsible for quality. Everyone is responsible for quality. Testers are really important. They're the people who find the bugs that you never would have thought of, who do exploratory testing, and who help to build and maintain the suites of automated tests. But they're not responsible for quality. All of us are responsible for quality. The job of testers is to make the quality of the system transparent so that you can then make decisions about what to do about it. But they're not responsible for quality. We need to build quality into our products, and that means we all need to take responsibility for it. So I'm going to gloss over this and just say, well, listen, there's this guy called Brian Marek who invented this thing called the test quadrant diagram, which categorizes tests according to two axes, whether they critique the product or whether they're support programming, and whether they're technology-facing or business-facing. This basically describes all the kinds of tests that you should be doing on your software, from unit tests that are written by developers that test small sections of the code in isolation, to the opposite end, which is all the manual stuff that people should be doing because it requires intelligence and imagination and all those things that computers don't yet have, showcases, usability testing, exploratory testing. And then These other quadrants, functional acceptance tests, the tests that the software delivers the expected value to its users, and down at the bottom here, the stuff that everyone forgets until a week before release to production, which is performance testing, testing security, all those things that make sure your site actually won't go down the moment it's launched, or that your credit card details won't get stolen, or all these other kind of less critical, non-functional requirements. I'm joking. All these things you should be doing all the time. And the way you do that is, firstly, you have to create those tests, but then you have to create a deployment pipeline to run them. What's a deployment pipeline? It is this. You have a process for going from check-in to live. The deployment pipeline is the manifestation of that process. It's a way to model and get visibility into that process, to get feedback on any change you introduce to the configuration or code of your system, and to get control over that so that people can self-service the actions they require, like provisioning a testing environment with the latest build, or deploying to staging or production, without having to raise a ticket and wait for a week for someone to provision an environment so that you can deploy to it. All this stuff should be push button, and it should be automatic, and everyone should be able to see what's going on, and everyone should get rapid feedback on the effect of the changes they introduced. So, the deployment pipeline looks a bit like this. The idea is I make a change, I check it in, that triggers a build of the system and running the unit tests. And if that breaks, this should take a few minutes. Certainly no longer than 10 minutes. And then I get fast feedback. Did the change I introduced break something? If it did, everyone stops what they're doing. Someone volunteers to fix the problem. No one can check in unless they're checking in to fix that problem. Or you might revert if it's going to be a difficult problem to fix. Once that has been made to work, then you trigger the next stage, which is running a comprehensive suite of unit tests. So the feedback is slower because they're more comprehensive, but it's more comprehensive. So this might take a longer, an hour or two. Large products have tests that might take days to run end-to-end. You run them in parallel on a massive grid, and you get rapid feedback. Google had, I think, tens of millions of tests, and they run them in less than an hour, I think, in parallel on their massive compute grid. So if this fails, then again, everyone stops what they're doing, someone volunteers to fix the problem, and then everyone else can carry on working and checking in, but there's someone whose highest priority is to keep the system working. And this is really important. With continuous delivery, you don't prioritize functionality. You prioritize keeping the system in a good state. Keeping the system working and in a good state is more important than delivering functionality. So that's the most important change. If something is broken, you stop the line and someone has it as their highest priority to fix that problem. And then once you have a build that the automated tests pass, someone downstream gets a notification, this is deployable to production, or this is deployable to a staging environment. They can then press a button and deploy that build or any other build of their choice to the staging environment. And if the user acceptance testing shows that the functionality is what actually we wanted to do in the first place, then someone can press a button with the appropriate authorizations to deploy that build or any other build into production. And the idea is this. The deployment pipeline, every check-in results in a build. Every build is a release candidate. Every build is a release candidate. And what the deployment pipeline is doing is testing the build. The build is like a mythical hero in a Greek epic. And the mythical hero wants to marry the beautiful woman, but first he must pass a series of tests. He must fight the evil monster and get the big bag of gold and descend into Hades and have an emotional reunion with his father. And then, once the hero's passed all these tests, then he can marry the beautiful woman. And this is what we're doing with the deployment pipeline. Every check-in results in the build, and you're trying to prove that the build is not deployable. And if you can't prove that the build is not deployable, then the build is deployable, and you can press a button and deploy it and not worry. And if you have even the slightest amount of adrenaline in your bloodstream when you press that button to deploy to production, what that tells you is that your validations are not good enough, and you need to make them better. So it becomes very simple. But what's not simple is convincing your organization that you have to prioritize keeping the system in a good state over delivering functionality. That's the hard conversation. I'm not going to solve that problem for you in this talk. So we're kind of running short of time. I'm just going to make a couple more points and then skip to the end. One of the key things that continuous delivery aims to do is reduce the risk of release. People don't like continuous deployment because they think it's risky. This is actually not the case. What's risky is releasing once every 2 months an enormous raft of changes that you can't possibly know the effect of over the course of a weekend and then having it go horribly wrong and trying to fix it or roll it back. What's not risky is releasing a 3-line code change which you validated and run a complete suite of regression tests against, using a production-like data set into production, and then being able to revert that change if it causes any problems with it almost immediately in a very simple way. That's low risk. And continuous delivery aims to reduce the risk of delivery because you have all these validations you're running, and if something goes wrong, it's super easy to fix it because you know what the root cause is. It was this 3-line change, or this configuration change in Apache, or this database schema change I made, and it's really super easy to revert it. That's how we reduce the risk of releases. So you need to automate provisioning and deployment and ensure developers, testers, and operations people collaborate throughout the process. This is the essence of, who's heard of DevOps? Anyone heard of DevOps? Okay, so DevOps basically is this, saying everyone should collaborate and we should find ways to automate the process to reduce the risk of delivery. The problem is operations people are rewarded for things not going wrong, whereas developers are rewarded for getting releases out. And those two goals are in conflict. So that goes wrong all the time because for operations people, change equals risk. So they want to prevent you from making any changes. Whereas for developers, you want to change things. DevOps is about saying, well, listen, actually, these two things are not in conflict. And we can find a way to ensure that everyone is happy. And the way we do that is making developers responsible for things going, when things go wrong, the developers take some of the responsibility for that. And it's actually the developer's problem if the system goes down, not just the operations people. So there's a whole set of practices and patterns around this that I don't have time to cover now. I kind of want to skip to the end at this point. There's a lot more I could go on for hours about this stuff, but it's nearly lunchtime. I don't want to be between you and your lunch. So the last thing I kind of want to say is that none of these problems about implementing continuous delivery are technology problems. The tools, the patterns, the practices all exist to make this work today, however weird or hard your environment is. You can do it. I'm not saying it's going to be easy. It could be really hard, especially if you're working on a legacy code base in C++ of 10.5 million lines. I went to an organization recently that had this system and they wanted to do continuous delivery, and I'm like, well, guess what? It's going to be hard. But nevertheless, it may be really valuable for you to do it. So all the problems really are people problems, not technology problems. It's possible to do this. Large organizations are doing it. All the stuff we talk about in the book, continuous delivery, is stuff that's been tested and is known to work even in really large distributed organizations. So first of all, when you're doing this, you have to get everyone together at the beginning. So anytime you're planning a new project, anytime you want to make a change to the way people work, a process change, you have to get everyone together and make sure that everyone's on the same page and they understand the consequences of what we're going to do, and that it's going to suck for a bit, and that it's going to be hard, and make sure that everyone is actually on board with it. And then keep meeting throughout the process. The most important agile practice is the retrospective, because that's the heartbeat of any change of an organization. It's where you say, here's an experiment we're going to try. Maybe we're going to try automating some more tests. Maybe we're going to try doing some continuous integration. Maybe we're going to try checking in on mainline. You run an experiment, and then in 2 weeks, you come back and you look. What happened with that experiment? Was it any good? Was it the right thing to have done? And you evaluate it. You actually don't need anyone to tell you the practices that you need to do. All you need to do is get together as a team every couple of weeks, run experiments, find out what the results of the experiments were, and then run some more experiments. And that's how you get better at what you're doing. That's it. That's how you make things better. All of you could go home or go to work right now and do that and make something slightly better. I mean, that's really the message of DevOps in some ways, that everyone has the power to make things slightly better, just by going and talking to other people and finding out ways you can collaborate to make things a little bit better. Visibility is really important, making it easy for everyone to see what's happening. Is the latest build deployable? Are we able to meet our performance requirements? How are we progressing, in terms of actually functionality that's deliverable, not functionality that's dev complete? And then, like I say, continuous delivery isn't a project that you're done with. It's part of continuously trying to make things better at what you're doing. And everyone can do that, and that's really the essence of it. So that's all I wanted to say. I know we're kind of at 12:30, but hopefully, since I started 5 minutes late, there's time for a couple of questions. The question is, what do I think about tools like Lightbox that allow for more immediate feedback? Well, ThoughtWorks is actually one of the initial investors in Lightbox. It's something that we think is a really awesome product. I mean, there's a great talk by a guy called Brett Victor, that I can't remember the title of, but if you search for Brett Victor, B-R-E-T Victor on Vimeo, you'll get his talk, and it's super awesome. And he basically says, it's impossible to be creative, if you can't see what you're doing. You need to be able to see what you're doing. And that essence of creating things and being able to change something and see the results of that change, that's what enables us to be creative. And if you have to wait hours, days, weeks to see the result of the changes you made, it makes it impossible to be creative. It makes it impossible to run experiments in code. So really, continuous delivery, fundamentally is about reducing that cycle time, maximizing feedback and getting as much feedback as fast as you possibly can. And yeah, absolutely, development tools where you can make changes to the code and see visually what the effects of that change are on a running system. It basically is a REPL environment that shows you immediately what the effects are on a bunch of input parameters. It's really super cool. Absolutely, I think that's a really great tool. Inventing on Principle was the talk by Brett Victor. Yes, thank you. So the question is, how do you address security in continuous deployment? Well, the general rule of continuous delivery is this. If it hurts, you should do it more often and you should bring the pain forward. So if it's painful to get security right, you're not doing it often enough. If you're waiting until your project is dev complete and then you get the security dudes in and they tell you, oh, you've got these cross-site scripting problems and SQL injection, guess what? You're not doing that testing often enough. You should be doing it all the time. So there's static analysis tools to look for buffer overruns, to look for SQL injections, to look for cross-site vulnerabilities. You should be running those static analysis tools on every check-in as part of your CI commit build. You should be running automated tests that test for security. You can run penetration tools. They take a bit longer to run, but you can run that as part of your acceptance testing. All these things should be built into the delivery process. High security is a quality of your system, and we're trying to build quality into the system. Quality is value for someone. That's how Jerry Weinberg describes quality. And security is part of the quality of your system, so build it in. Find ways to bring it forward in the pipeline, to run those validations as often as you can. Some security tests, you require people to do it. You should be doing that as often as you can, somewhat further down the pipeline, because you don't want to run manual tests against a build that's not known to be good in other ways. But yeah, bring it forward as much as possible. And then how far you bring it forward depends on the trade-off between the availability of the resources you have and the quality of the initial feedback you get. But yeah, does that answer your question? Maybe one more? One more, yeah.
One of the things I like to say is that if the production site was running on the box under my desk, we'd never have any bugs, or we'd have bugs, but they'd be eliminated quickly. One of the problems, the only thing I have problem with conceptualizing in my mind is how do you convince, how does the Scrum process break down whenever you're releasing before a sprint ends? That part is confusing me.
So that's an excellent question. Scrum says that your software should be in the deployable state at the end of a sprint. I'm saying that's not good enough. Your software always needs to be deployable, and then you can choose to deploy it whenever you want. InView, down in Silicon Valley, they were this guy at InView called Timothy Fitz wrote the continuous deployment blog entry. And I went to talk to InView a few weeks ago, and they basically said, well, listen, we do Scrum. And I'm like, really? And they're like, yeah, but we don't wait till the end of the sprint to have software deployed. We deploy it all the time. We're still doing Scrum. And the point is, I think the world has moved on since Scrum was invented, and we now have these principles and practices that allow us to do better. It used to be that people thought having deployable software at the end of a sprint was crazy talk. We release once a year, and you're asking us to be deployable once a month? You're insane. Oh my God, we can't possibly do that. The world has moved on. We have tools that make it possible to do this stuff that I'm talking about. And we can do better, and we should do better. All this stuff, there's a trade-off. There's a cost associated with implementing maintainable, comprehensive, automated tests with continuous integration. There's a cost for all this stuff. And you have to decide, is it worth it for me to be able to do this? There's always a business decision that's involved. But the reality is, everyone is moving faster and faster and faster, and it's almost impossible to remain competitive unless you're in a massive monopoly, unless you're actually doing some of this stuff and testing your hypotheses about what to build. So, people are already proposing modifications to Scrum to say, well, actually, we shouldn't do this. Scrum can be fine as a kind of a shell around the planning process, as a planning methodology. But I would say, the reality is, Scrum is a great starting point if you're really immature. Any practice that's written down in the book is a good starting point. Kanban, Scrum, whatever. Even waterfall can be a good starting point if you're doing something totally chaotic. There was a Forrester survey looking at development methodologies, and the most popular development methodology last year was no development methodology. If you have no development methodology, waterfall might be an improvement on that. So start with something and then practice continuous improvement. I think that's probably it. Thanks, everyone.